box is pulled east along a horizontal surface with a force of 60 newtons, acting at an angle of 42 degrees. If the coefficient of friction is 0.230, what is the acceleration of the box? So again, we're going to assume that this acceleration is horizontal. So we are assuming that the box is not floating up or falling down. So let's draw our box with our free body diagram. So FG goes down, FN goes up, FF is pulling back, and here though, our FF is at an angle. So you need to break it down into F at X and F at Y. So again, we're looking for acceleration, so we know we need to find F net. So since I'm finding horizontal F net, that's F net X. So my overall equation, F net X, is equal to F at X plus a negative F F. Which then we can say F net X is equal to F at X minus F. All right, so let's see. What do we need to find? Well, we were only given okay, so we were given our mass, the magnitude of FF overall, and our coefficient of friction.
Would F net be like would F net Y be 0?
F net, no, F net Y, like, or sorry, this one? FFY, you mean?
Well, no, because you can find FG, right?
Yes.
To find Fn,
Right.
would you let F net equals 0?
Oh, of that, yes. Yes, you would. So, very good. So Lisa went to the point, okay, I can find my FX using a trig. And then she says, well, with F, to find my FF though, I'm going to have to use my coefficient of friction and my Fn, right? Because we know FF is equal to mu Fn. We're given our mu, but we need to find our Fn. We find our Fn by finding our Fg. So very good. All right, so this one has, yep?
My question was why do you have F net set as 0?
Oh, because there's no vertical acceleration.
There's no point.
But we still assume that the box is still traveling, like on the ground.
Oh.
Yeah, so the object is still moving this way, even though it's being pulled up. Yeah. Because the mass is holding it down on the ground. If it was something really light, then it would like go up, right? But yeah. Okay, good. All right, good questions. Okay, so let's do stuff. Okay, so we can find our F at X by going cos 42 equals F at X over F. So cos of 42 degrees times by 60 newtons is equal to our F at X. So F at X is equal to 44.5886 newtons, etc. So, one thing now, when we're considering our Fn, this is a vertical vector. So we need to take all of our vertical vectors into account. So our Fn, our Fg, and our F at y. So those are all vertical vectors that we need. So we need to find our F at y for this question, since as a part of our free body diagram it is a vertical. Sorry. So our F at y is sine 42.
Question.
Yep.
Why do you need your F out Y?
Because it is a vertical component, and I need to find Fn to do my mu Fn to find
Your
Ff.
FG.
You don't need to find that y, just use FG.
Was Fn equals FG?
But not for this question, because normally it does, right? Because normally we can say F net is equal to Fn plus Fg, right?
Yeah.
But it's because we know that this happens like a lot in our questions because that's adding our vertical components together. But we have another vertical component that we haven't done before. Okay? Because we're pulling something at an angle, we have another vertical component.
So why didn't we use it in the last question?
Because we were given the coefficient of friction, so we didn't need to do a calculation to find out FF. So we didn't need Fn, so we didn't need to look at the vertical. Good question. Okay, so now for this question, F net of our y is equal to Fn plus Fg plus what? F at y. Yeah. Okay. But as you suggested before, F net y you can set to 0. Okay, so I'll just continue with this calculation and then I'll kind of explain what I was just talking about there. So F at y, sine 42 is equal to our F at y over F at. So sine 42 times by 60 newtons is equal to our F at y. So 40.1478 newtons is equal to F or FAPI, because that's more fun, right, Dylan?
Yep, check your 7L in there. It's flappy.
Right. It would be. Okay, so now what I was talking about before, our F net y is equal to Fn plus our negative Fg plus F at y. So let's just make a note to ourselves here about why we're doing this, just so that if you look back you can see. So we need to consider F net y because I need Fn to calculate F. So I'll just give you the big picture. Perhaps I should have started with this. You guys can let me know. Because overall, this is what we're trying to find. F net x is equal to F at x plus negative FF. Well, we don't have FF, so we had to go F net x is equal to F at x plus our negative, I'll just set this to minus mu Fn. this is why I need to do this calculation. It's because I need that Fn.
I'm gonna grab my coat, it's kinda cold.
Are we with me? How are we doing?
So is Fn still negative FG or?
Mm-mm. So maybe I should continue and you might see? Like, because we need to have Fn plus negative Fg plus F at y. So we need to consider all of them.
Is it just because something's the angle is going to result in like a
Exactly, yes, it is. It's because the angle is pulling up, and so we have a vertical component more than just Fn on Fg. Because before, if something is just, if the FF is just going sideways, there's nothing pulling up or down. So of the object, there's only ever been Fn and Fg for vertical movement. But this is pulling at an angle. So we need to consider the vertical component of being pulled at an angle. So now, yeah, we set F net to 0 because no vertical acceleration. So it's not like accelerating up or down. So then we can say Fn is equal to Fg minus F at y. Normally, it would just be Fn is equal to Fg. That's why this is kind of a different scenario. So now I'm going to just substitute in for what I know Fg is and what I have for F at y. So Fn is equal to then 12.7 kilograms multiplied by 9.81 meters per second squared minus 40.1478 newtons. So then I can say that my Fn is equal to 84.4391, etc. newtons. Now I can find Ff, because I know that Ff is equal to mu Fn. So this is 0.230 times by 84.43916 newtons.
Since that's F, where did I get to
Okay. So our FF then is what?
Why is it a minus 40? Why is it like plus 40?
Because of rearranging, I think. So our FF is 19. I can go back to that in a second if it's not clear though. Okay, so now we go back kind of to the beginning overall concept of F net is equal to F app plus FF, which we know we set to negative. So F net is equal to 44.5886 newtons minus 19.42097 newtons. So F net is equal to so our actual question was A is equal to F net over M. So A is equal to 25.16763 newtons divided by 12.7 kilograms. So A is equal to 1.9817 meters per second squared. Sig digs in direction, it is 1.98 meters per second squared. So when you're doing these questions, if you feel comfortable in it and you like it better, you could substitute directly in. So when you knew that F net x is equal to F x plus negative FF, you could say F net x is equal to F minus mu n. You could jump to a spot like that because, you know, when you're just rearranging, but that's kind of an advanced doing several steps at one time. For me, I kind of like to figure out each force separately and then put it back into the equation that I need. Depending what you like to do is up to you.